Hi, Loveland Tigers. Today we are going to be working on subtracting mixed numbers, focusing mostly on the models, and then tomorrow's lesson will be focusing mostly on the algorithm. So I want to start with your math book. You should have that with you. And on page 301 is the solve and share. Go ahead and read it yourself, but I'm going to go ahead and read it out loud as well. Claire and Aaron volunteered at an animal shelter a total of 9 and 5/6 hours. Claire worked for 4 1/3 hours. How many hours did Aaron work? You can use fraction strips to solve this problem. You have a fraction strip tool available to you through Solvus, and it's actually right up there in the upper right-hand corner. It says fraction strips, and you can pull that down, or you can draw a model, or again, solve it any way that you would like. So we are on page 301. I'd like for you to go ahead and pause the video and solve that question in any way that you would like. Once you have solved that question, please go ahead and restart the video. Okay, so one of the ways that we could have solved this using fraction strips is to start with our 9 and 5/6 because that's the total amount that they had. So if this was 1 whole, I would need to draw 4 of these, or I'm sorry, I need to draw 9 of those. Okay, so I went ahead and drew my 9 and 5/6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 5/6. You can see that this whole is broken up into 6 pieces, 9 and 5/6. So I'm going to go ahead and shade that in as if that does not exist. I'm going to be subtracting. We start with our whole number, subtracting 4. So 1, 2, 3, 4 right there, taking away those 4 whole, and 1/3. I know that 1/3 is equivalent to 2/6. So I'm going to go ahead and cross those out. All right, so that leaves me with 1, 2, 3, 4, 5 whole, and 1, 2, 3, 3/6. Then we know that 5 and 3/6 is equivalent or equal to 5 1/2. So that is one way that you could have modeled this question. You also could have used our skills from yesterday in the class where we were adding mixed numbers. Using the algorithm, you would solve this the same way as you would adding mixed numbers. You would solve this the same way, except for that last step would be subtracting instead of adding. Okay, now that we've completed the solve and share, we are going to go ahead and look at the short video for visual learning. If you'd like to follow along in your book, that is on page 302.
How can you model subtraction of mixed numbers? Think about this question during the lesson. James needs 1 11/12 inches of pipe to repair a small part of a bicycle frame. He has a pipe that is 2 1/2 inches long. Does he have enough pipe left over to fix a 3/4 inch piece of frame on another bike? What type of numbers are you subtracting? What is your plan for solving this problem?
Okay, so I want us all to have an idea in our head about how you would tackle this type of question.
You are subtracting mixed numbers. A possible plan is to change the mixed number 2 1/2 to a fraction with a common denominator 12. You can then model the problem with fraction strips. What is an equivalent fraction for 2 1/2 with a denominator 12?
Select your answer.
So if we're looking at with a denominator of 12, 2 1/2, denominator of 12, I would be multiplying 6 over 6. So 2 and 6/12.
Rename 2 1/2 as 2 6/12 so that the fractions have a common denominator. Step 1. Model the number you are subtracting from. 2 and 6/12. If the fraction you will be subtracting is greater than the fraction part of the number you model, rename one whole. Since 11/12 is greater than 6/12, rename one whole as 12/12. Step 2. Use your renamed model to cross out the number that you are subtracting, 1 and 11/12. There are 7/12 left, so 2 and 1/2 minus 1 and 11/12 equals 7/12. What is an equivalent fraction for 3/4 with a denominator of 12? Why is there not enough pipe left? An equivalent fraction for 3/4 with a denominator of 12 is 9/12. There is 7/12 inch of pipe left, and James needs a 3/4 or 9/12 inch piece of pipe. 7/12 is less than 9/12. James will have 7/12 inch of pipe left. He does not have enough for the other bike. Solving problems is fun. Now you know how to model subtraction of mixed numbers.
So we're going to do a couple practice questions where we are reading the models together. So this is on page 303 of your book. We're looking specifically at questions 6 and 7, and I picked these ones because they use the actual models. So Terrell lives 2 5/6 blocks away from his best friend. His school is 4 1/3 blocks away in the same direction. If he stops at his best friend's house, how much further did they have to walk to school? So you can see that this model here, that part of it is done here for us. We have 2 and 5/6. His school's 4 and 1/3 blocks away. So that 4 and 1/3 represents the total amount of blocks away. So this is going to be 1 whole, 2 whole, 3 whole, 4 whole, and then this represents 2/6, which is equivalent to our 1/3. And Terrell lives 2 and 5/6 blocks away from his best friend. So I'm essentially subtracting or taking away 2 whole, which is what's happening here, and then 5/6. 1, 2, 3, 4, 5. So you can see the part that does not have x's on it is what our solution would be. So as an equation, 2 and 5/6 minus 4 and 1/3, 1 whole, 1, 2, 3, 3/6, which again, if you're comfortable putting that into its lowest form, is 1 and 1/6. So at this point, I'd like for you to go ahead and try question number 7 in your book. Pause the video, try question number 7 in your book. Once you've completed it, come back to check your work. Okay, so you may have realized that there's some unnecessary information in here. What the question is asking is how much cheese does she have left? So it says nothing about turkey. That is unnecessary information. So I do need to know that she bought 2 1/4 pounds of cheese, 1 whole, 2 whole, and then this is the 1/4. How's that represented? She used 1 1/2 pounds of cheese. So we crossed off our 1 whole fraction strip and then 1/2, which in this case is 2/4. And I have 1, 2, 3, or 3/4 pound of cheese left. And as an equation, we have 3 1/2 minus, oh, no, we do not. We have 2 1/4 minus 1 1/2 equals 3/4. And again, we're talking about pounds of cheese left. Okay, I am going to go ahead and start discussing with you how we can use our algorithm as well, because you're going to see that pop up on some of your practice. So I'm going to flip the camera here. So you should be able to see my adding and subtracting mixed number mat at this point. I'm going to go ahead and pull some questions that are actually in your book. So for example, question number 8, that's in your book on page 303. We have 12 and 3/4 minus 9 5/8. All right. First thing we're going to do is find the least common denominator. My denominators there are 4 and 8. So I'm going to list my multiples. And I'm sure that most of you saw right away that our common lowest denominator would be 8. So 12 and 3/4, I'm going to convert the fraction into equivalent fractions with common denominators. I need now a denominator of 8. I'm multiplying by 2 over 2. So 12 and 3/4 is equivalent to 12 and 6/8. And then I'm going to subtract 9 and 5/8 from that. So just like when we were adding, we are going to subtract the fractions first and then deal with our whole numbers. So 6 minus 5, my numerators is 1, denominator stays the same. And then 12 minus 9 is 3. So 3 and 1/8. Okay, friends. So from this point, that is going to conclude our mini lesson on using models to subtract mixed numbers.